Hello, calculus folks. This example 2 from day 1 of our uh, review days, and in this one we're going to remember how to do derivatives from first principles. And remember the formula from first principles. The limit as h approaches 0 of f at x plus h, but not f, so I'm going to use s at t plus h minus s at t over h. And remember, this is essentially, this is just the slope, right? This is the rise and this is the run. When over here we have, well, s at t is just 1 over 2t. S at t plus h then is 1 over 2 times t plus h. And I substitute those things in. And remember, the whole idea is I want to get rid of this h, because dividing by 0, that's bad, and we want to not do that. So how we handle these fraction ones, remember, is we don't like having this subtract this over that, so we write the 1 over h kind of out front, and then I'm going to write this in brackets. Subtract that. And each of these first principle ones, just like the limits, they kind of have a way, a trick, not a trick, but a strategy, a solid strategy. And when it's a fraction one, we want to get a common denominator, right? So we want to get a common denominator, and the common denominator here, we have to have that expression and we have to have that expression. So I'm going to have 1 over h. One of those is this mess, and one of those is this mess. I suppose I only needed 1, 2, didn't I? So let's fix that up. Only one. We only need 1, 2. Tin pen. There. And so here, what did I need to multiply by this expression to get to the common denominator? Well, just t. Writing down that minus sign. What did I multiply by this expression to get to the common denominator? T plus h. And then what do we got? Still have a limit. Remember your style here. The equal sign is in front, and this is the limit we're evaluating. And just like we knew, t minus t, that's going to get rid of the t, and I'm left on the top with minus h over t plus h in brackets and then t. And just like we knew it was going to work, I can cancel the h and the h. This leaves me with minus 1 here. And now, in this expression, I'm going to rewrite this. Minus 1 over t times, or 2 times t plus h times t. Notice that right now, it's okay for h to be 0, right? 0 is in there, and this is going to give me an expression that's okay. So I'm going to let the limit go to 0, and then I'm left with 2t squared. So therefore, s prime at t is equal to negative 1 over 2t squared. Just in passing, remember from our derivative rules now, if I have 1 over 2t, I could have written this one like this, right? Minus 1 comes down. Subtract 1 off the exponent. It's exactly the same thing. Right? Same thing. Yay. Full marks on that one. All right, that's it for this example.